basically self dot variable name. Like this could be width, for example, right? And this works. This is basically setting a property for the current object named width, and we're setting it equal to this parameter that we passed in. I want one by one entities, so I'm going to do size. There's going to be no width and height. It's just going to be one size for both the width and the height, which will create a one by one aspect ratio. Self.health is going to be equal to the health, and then the self.sprite is going to be equal to pygame.image.load, which loads as an image. The only thing that you have to pass is the file name, which is going to be our image path. And then we want to convert it to alpha so that it will have a transparent background. And I believe that's a method, so we have to put the parenthesis. Next, what we have to do is we have to scale, because we just created this image, but we have a size here, so let's scale it to that size. Let's do self dot sprite dot, or no, yeah, self dot sprite is equal to pygame dot transform dot scale. We have to first pass the surface, which is the sprite, and then we have to pass in the size, which is going to be a tuple, which we can create a tuple with our self dot size as both the x and the y. Now we'll have a sprite at the correct size. Now the last thing we want is a rect. A rectangle is going to be used for collisions. So all we have to do is just do self.sprite.getRect. And what this will do is it'll get a rectangle the same size as the sprite. Now what we can do is we can create some methods that we can call. I want to create a method named takeDamage, because both the tower and the enemies will be able to take damage. The only parameters will be self, because a class function needs to pass self so we know which object we're talking about, and the amount is going to be the amount of damage taken. So self.health is going to be minus equal the amount. And this works because this is the same thing as saying self.health equals self.health minus amount. It's just a quicker way to write this. Next, what we're going to want is we're going to want a draw method. So we can call object.draw from main, and we can just draw each object like that. So def draw is going to pass self, and we're going to want the screen that we're drawing to. What we'll do is we'll do screen.blit. What this blit does is it allows you to put a surface onto another surface. So what we can do is we can pass this screen, what we want to blit onto, and we can pass the self.sprite, which is what we want to actually put onto the screen. And then the flip over here will actually display that. And then we want a update method. And this will pass in the screen, and it will pass in delta time, the amount of time that's passed. And we'll just call self.draw right from here, passing in the screen. So now we can create an entity, but our tower and our enemies are different. So that's why we create separate classes for those too. So for the tower, we have to import the class that we just created from entity. So we can do from entity, from the script, we can import the entity, notice the uppercase class. With this, what we can do is we can create a class tower, and inside of parentheses, we can write entity. This means that all of this logic that we've written here applies to this class as well, unless we change it, unless we override it. So we can create the init function again, and we're going to pass in the same things as this one here. So we're just going to simply copy it and just paste it in, because there's no need to write it twice. And now what we can do is we can call all we call is super. what super does is it calls the entity init function. If we do dot underscore underscore init, and then we can just pass in all of these variables here. And then notice here, we can get the self.x and we can get the self.y, even though we didn't create it here, and that's because we created it here. Now, nothing else has to actually change about the tower as of right now. So what we'll do is we'll just leave this as is, and we'll move on to the enemy, and we'll copy this because it's going to start out the same. This will be enemy. Now, what we can add is we can add a few more parameters. One thing we want is the speed of the enemy, we want the damage of the enemy, and we want the direction of the enemy. I believe that's everything we're going to need for right now. So we can initialize these like this, and self.direction equals direction. Now we want a method that that moves the enemy during the tick. So what we need in here is we're going to need the delta time, the amount of time that's passed. So the way that we do this is we have to get the amount of distance that they've moved. So that's going to be distance or displacement, whatever you want to call it. Distance is equal to the speed that's going times delta time. So speed, it's self.speed. Speed is going to be how many pixels per second they're moving. So if delta time, if it's been 1 second in between frames, then the object needs to move like the 100 if the speed is equal to 100. But if delta time is like 1/10 of a second, then we only want to move 10 pixels instead of 100. Okay, now we have to divide that up into x and y's because we can't just go in a diagonal. So what we're going to do is the x distance is equal to, what we need is we need math. So we need to import math, because what we can do is we can do math dot cosine of the self dot direction. What this will do is it'll get a number, it'll get a number between 0 and 1 that we can, I think 0 and 1. But it'll get a number like in the y distance and x distance will add up to a total of this distance. Or it'll add up to a total of 1 right now. But if we multiply 1 by distance like this, what it will do is it'll make it so that the two of them will add up. It'll create a vector, a hypotenuse of a triangle, basically. Like this is the bottom of the triangle, and this is the height of the triangle. And then the result will be a hypotenuse or a vector of this distance in the self dot direction. So when we do that, now what we need to do is we need to update the enemy position. So what we can actually do is instead of doing x distance and y distance, what we can just do is we can just do self.x and self.y. And the reason why is because I actually missed something. Now that I realize that, I actually messed up here in the screen.blit. We don't need to pass screen because they already know that it's the screen from this. What the second thing is it's actually a tuple of where it needs to be displayed, which is at self.x and self.y. That's the position of the object. So back to here, when we update the self.x and the self.y, when this update here is called, or this update is here called, it'll call draw and it will display at that x and that y. The next thing we want to do is we actually want to update our rect. So our self.rect dot top left. So this is going to be where the top left of this rectangle is equal to, because Pygame positions are not at the center of an image, it's at the top left of the image. And we're just going to set this equal to